Now on Nova. Take a thrill ride into a world stranger than science fiction, where you play the game by breaking some rules, where a new view of the universe pushes you beyond the limits of your wildest imagination. This is the world of string theory, a way of describing every force and all matter, from an atom to Earth to the end of the galaxies, from the birth of time to its final tick, in a single theory, a theory of everything. Our guide to this brave new world is Brian Greene, the best-selling author and physicist.
And no matter how many times...
The heart of all reality. But it comes at a price. Parallel universes and 11 dimensions, most of which you've never seen.
We really may live in a universe with more dimensions than meet the eye.
People who've said that there are extra dimensions of space have been labeled crackpots or people who are bananas.
A mirage of science and mathematics? Or the ultimate theory of everything?
If string theory fails to provide a testable prediction, then nobody should believe it.
Is that a theory of physics or a philosophy?
One thing that is certain is that string theory is already shown.
And security. Major funding for NOVA is also provided by the Corporation for Public Broadcasting and viewers like you. Thank you.
Imagine that we were able to control space. Or control...
It's a particularly exotic or strange notion.
No wonder physics students are lining up to explore the strange world of string theory.
String theory is very active. Things are happening. There are a lot of people doing it. Most of the young kids, given the choice, at a ratio of something like 10 to 1, they will go into string theory.
But strings weren't always this popular. The pioneers of string theory
shocked everybody, but then we learned to live with it.
But M theory would go even further, demanding yet another spatial dimension, bringing the grand total to 11 dimensions.
We know that there have to be 11 dimensions for this theory to make sense. So there must be 11 dimensions. We only see 3 plus 1 of them. How is that possible?
For most of us, it's virtually impossible to picture the extra higher dimensions. I can't. And it's not surprising. Our brains evolved sensing just the 3 spatial dimensions of everyday experience.
The more dimensions or degrees of freedom you have, the more you can do.
That's right.
And if there really are 11 dimensions, then strings can do a lot more too.
People found fairly soon that there were objects that lived in these theories, which weren't just strings, but were larger than that. They actually looked like membranes or surfaces.
The extra dimension Witten added allows a string to stretch into something like a membrane, or a brain for short. A brain could be 3 dimensions.
And if these ideas are right, the bulk may have other slices, other universes that are right next to ours. In effect, parallel universes.
Not only would our universe be nothing special, but we could have a lot of neighbors.
Some of them could resemble our universe. They might have matter and planets and, who knows, maybe even beings of a sort. Others could certainly be a lot stranger. They might be ruled by completely different laws of physics. Now, all of these other universes would exist within the extra dimensions of M theory, dimensions that are all around us, Some even say they might be right next to it. May help solve one of the great mysteries of modern science. It has to do with gravity. It's been more than 300 years since Isaac Newton came up with the universal law of gravity, inspired, as the story goes, by seeing an apple fall from a tree. Today it seems obvious that gravity is a powerful force.
It would seem to most people that gravity is a very important force. It's very strong. It's very hard to get up in the morning, stand up. And when things fall, they break because gravity is strong.
It turns out that electromagnetism is much, much stronger than gravity. Gravity, in comparison, is amazingly weak. How weak?
The electromagnetic force is some 1,000 billion times stronger. That's a 1 with 39 zeros following it.
The weakness of gravity has confounded scientists for decades. But now, with the radical world of string theory, filled with membranes and extra dimensions, there's a whole
nothing. And I'm not a philosopher, so I won't say, but I can imagine to a philosopher that is a problem. But to a physicist, I think it's also a problem.
Everyone admits there are problems. The question is, can string theory solve them? Some string theorists have suggested that the Big Bang wasn't the beginning at all, that the universe could have existed long before.
Explanation.
So what is the explanation? What if string theory is right, and we're all living on a giant membrane inside a higher dimensional space?
One of the ideas in string theory that was particularly striking to me and suggested perhaps a new direction for cosmology is the idea of brains and the idea of brains moving in extra dimensions.
Some scientists have proposed that the answer to the Big Bang riddle lies in the movements of these giant brains.
It's so simple. Here's a brain on which we live, and here's another brain floating in the higher dimension.
If string theory is the one true theory of the universe, it will have to solve the riddle of the Big Bang. And there's a lot of hope that someday string theory will succeed. But for now, there's also a lot of uncertainty. As promising and exciting as the theory is, we don't entirely understand it.
It's as if we've stumbled in the dark into a house, which we thought was a 2-bedroom apartment, and now we're discovering is a 19-room mansion, at least, and maybe it's got 1,000 rooms, and we're just beginning our journey.
So, how sure are we that the universe is the way that string theory describes it? Is the world really made up of strings and membranes, parallel universes, and extra dimensions? Is this all science or science fiction?
Well, the question we often ask ourselves as we work through our equations is this just fancy mathematics, or is it describing the real world?
These exercises in our imagination and mathematics are all, at the end of the day, subjected to a single question. Is it there in the laboratory? Can you find its evidence?
String theory and string theorists do have a real problem. How do you actually test string theory? If you can't test it in the way that we test...
But all that has changed thanks to string theory. This is Fermilab, and right now, it's our best hope for proving that extra dimensions are real. Fermilab has a giant atom smasher. Here's how it works. Scientists zap hydrogen atoms with huge amounts of electricity. Later, they strip them of their electrons and send the protons zooming around a 4-mile circular tunnel beneath the prairie.
Opportunities for discovery.
If we do find sparticles, it won't prove string theory, but it will be really strong circumstantial evidence that we're on the right track. Over the next 10 to 20 years, the new generation of atom smashers is sure to uncover surprising truths about the nature of our universe. But will it be the universe predicted by string theory? What if we don't find sparticles or extra dimensions?
What if we never find any evidence that supports this weird new universe filled with membranes and tiny vibrating strings?
The Wright brothers took flight. Modern builders attempt to recreate the world's first airplane. But will their dreams take off?
Trees are coming up pretty fast.
Wright brothers flying machine.
Nova is a production of WGBH Boston.